Welcome to ClickMyProject.com. Now we are going to discuss about the project Deep Skin, a deep learning approach for skin cancer classification. Now we are going to discuss about the abstract of the process. Skin cancer is one of the most rapidly spreading illness in the world, and because of the limited resources available. In this process, we have evaluated the skin cancers by means of the early detection of the skin cancer is crucial accurate diagnosis of skin cancers identifications for preventing the approach in general. In this process, digital image processing is applied to detect the skin cancer as well as the type of the cancerous. Detecting the skin cancers at an early stage is challenging for dermatologists as well as in recent year both supervised as well as the unsupervised learning tasks have been made extensive use of the deep learning methods to classify the cancers as well as the type of the cancers. One of these models, the deep learning consists of the convolutional neural network has surpassed all other in object detection as well as the classification test. In this process also we are going to implement this convolutional neural network to detect the skin cancers as well as the types of the cancers. Finally, the performance of the classification will be evaluated by means of the accuracy, sensitivity and specificity. In this process it consists of three major steps like feature extraction, classification and performance estimation. These are the three major steps placed in this project to evaluate the skin cancers or not. Now we are going to discuss about the overall flow diagram of the process. This is the overall workflow of this project. This project consists the modules such as input image, pre-processing, feature extraction, classification, then finally performance estimation. These are the 5 modules presented in this project. At first, the input image is taken from the dataset images. Dataset images consist of lots and lots of images which is having both the cancers as well as the non-cancerous images. In case of cancers, it is having the type of cancers will be there, so that images also consist in this dataset. After that input image, the pre-processing will be carried out. In this pre-processing, there are 2 stages of pre-processing will be there. One is the image resize, then the second one is the histogram equalization as well as the channel separation. So in this image resize, the image will be resized into 256 × 256, which means the number of row will be the 256, number of column will be the 256. The reason for image resize in the sense, for example, if we are importing the images which is having the high resolution, in the sense it will take too much of the time to the execution. In case of low resolution, in the sense it will consider the low quality image. So the reason we are going to do the image resize into an optimum size. After doing this pre-processing, the feature extraction will be carried out. In this feature extraction, there are 2 stages of feature extractions will be there. One is the pattern type of feature, then the another one is the texture type of features. So in that pattern type of features, we are going to extract the local binary patterns, that is simply known as LBP. After extracting the pattern type of features, we are going to extract the texture type of features by using the deep learning, that is convolutional neural network. After extracting these two features are combined to generate the test features together. After that, we have to do the classification by means of the machine learning algorithm. In that machine learning, we have to classify whether the input is consist of disease or non-disease. It is having the disease, in the sense, first of all it will be denoted as a disease, then the type of the disease will be diagnosis here. After doing the classification everything, we have to evaluate the performance of the process by means of the accuracy, sensitivity and specificity. Using these 3 parameters, we can justify our process is efficient. Now we are going to discuss about the running procedure of the process. At first, open the Spider 3.7. After opening the Spider, we have to change the current directory like this. After that, we have to open the main file.py. Once you open the main file.py, you can see the coding in that. After that, we have to click this run button. Once you click the run button, the dataset will be open. In that dataset we have to select the image from the dataset. First of all, we can know about the what are the images present in that dataset. So these are the categories present in the dataset. Among that we have to select any one category as well as the any one image from the dataset. Once you have selected the image from the dataset, the corresponding image will be undergone to the process, and then the result will be shown in the console window. These are the results we have attained in this project. At first, the original image which we have taken from the user side. After getting the input image from the user, we have to do the pre-processing. You can see the difference between the input and then the pre-processed image. Now the input image having the dimension of around 500. After doing the resize, the image will be resized into an around 224. So this is the first stage of the pre-processing. After doing this one, we have to segregate the channels like red channel, green channel, blue channel. So we have to extract the red, green, blue channel separately. After doing this one, we have to convert the image into a grayscale format. After doing this one, we have to do the segmentation. Segmentation is nothing but we have to extract the only the affected portions, other the background regions will be eliminated. So this is the step we have done in the segmentation. You can see the result here. Only the affected portions will be turned as an white, so the backgrounds will be the neglected and it remains the zeros. Now the data splitting consists of the 80-20 ratio, which means the test data will having the 20% of data features, then the trained data having the 80% of features data. So after doing this one, the convolutional neural network is applied to extract the features everything as well as the local binary pattern. This is the results for the local binary pattern, which is used to extract the features from the images. Both the features will be combined together to generate the test features here. After generating the test feature, we have to find out the types of the diseases. So the type of the diseases will be shown here, as well as the accuracy and error rate will be shown here. Finally, the region of interest will be bounded by using the bounding box method.